let's do some simple examples working with infinite series and just get comfortable with working with the idea of partial sums. So what we want to do is we have a sequence that's defined here kind of explicitly, and then we have this one that's defined in terms of an arbitrary nth term. And what we want to do is just describe the first 5 terms. So to do that, we're going to say, okay, S1 is just the first term. So that's clearly 1 over 6. But the second term is the first term plus the second term. Well, this is 2 over 12, which is also 1 over 6. So we get 1/3. Now, the third term is the second term plus the next term in the sequence, which is 3 over 20. So that's going to get us 29 over 60 by getting common denominators. So the next term is this term plus the next term in the sequence. I apologize. FYI, that should have that trailing piece there. Plus the next, so we have this. Now this next term in the sequence is 4 over 30, which you could also write as 2 over 15. But we'll just write 4 over 30 because we're going to get a common denominator, 60 anyway. So that's going to be 29 plus 8 over 60. So 37 over 60. And then finally, we get 37 over 60 plus 5 over 42, which is pretty ugly. So the common denominator here, these have a 6 in common, but this has a 10 and 7, so 420 is actually my common denominator here. So I have to multiply this by 7, that gives me 259 plus 50, so 309 over 420. All right, 309 over 420. So this, these are our partial sums. So again, really, notice it gets kind of nasty pretty quick. If we took that out to 10 pieces, we'd have kind of a difficult time there. You probably want to use a computer to do that sort of thing, but sometimes it can be helpful by hand to get a little bit of intuition with what you're dealing with. Now, this one over here is a little more interesting because the sequence here, you have to say, okay, well, when I'm dealing with S1, okay, well, I have to deal with the case where n equals 1. When n equals 1, that's negative 1 squared over 1 factorial. So that's just 1, right? Because negative 1 squared is 1. And then 1 factorial is obviously just 1. So the next term is 1 plus negative 1 to the third over 2 factorial. So that's actually 1 minus a half. So that's 1/2. Now, notice in this case, we're increasing. But in this case, we're actually going to oscillate. And that's because we have that negative 1 up there. That negative 1 is going to make it positive in some terms and negative in the next term. So the third piece would be 1, and 1/2 plus negative 1 to the fourth over 3 factorial. Hopefully that makes sense. That's going to be 1/2 plus 1/6. So that's 3/6, 4/6. This is 2/3. The next term, 2/3 plus negative 1 to the fifth over 4 factorial. 2/3 minus 1 over 24. Right, because 4 times 3 is 12, times 2 is 24, times 1 is also 24. So I get 15 over 20. So I get 16 over 24 minus 1 over 24. That's 15 over 24. And then when we reduce, we get 5/8. And then finally, we get 5/8 plus -1 to the 6th over 5 factorial, which is 5/8 plus 1 over 120. 1 over 120. And if I get a common denominator, that's going to be 120. So that's 75 over 120 plus 1 over 120 is 76 over 120. But 76 is divisible by 4. So we can divide that out to get 19 over 30. I believe that's right. You know, if it's not, then shame on me. But this is the idea here. Now, I do want to point out one other thing. What we could have done, and arguably what we should have done, is instead of doing all this in one fell swoop, let's generate the terms of the sequence here, and then we'll add them. So I could have done A1, A2, A3, A4, A5. And following this pattern, I would have got -1, 1 plus 1 over 1 factorial. So I would have got 1 there, and then -1, the 2 plus 1, 2 factorial, -1 cubed for 2. So, sorry, I wasn't talking there, just sort of writing. But the reason that this can be useful to just write all these out is because then, instead of having to calculate it on the fly, I could have said, okay, I have 1, then 1 minus a half is a half, 1/2 plus a 6 is 2/3, 2/3 minus 1 over 24 is 5/8, 5/8 plus 120 is 19/30. So, instead of having to kind of jam it all in here, I could have followed the same sort of process that I did here, just kind of pulling from the list instead of having to think, okay, what am I adding and what am I generating? Sometimes that's too many steps to deal with at once.